an introduction of how to balance chemical reactions. So we have our reactants, the chemical formulas listed to the left of the arrow. Then we have our chemical formulas of our products written to the right of the arrow. The chemical formulas are correct as written, so element symbols with their subscripts. We can't change an element symbol or a subscript. So the chemical formulas are correct as written. Our job is to figure out what coefficients, the big numbers, we place out in front of each of these chemical formulas so that our atom count and type on the left matches the atom type and count on the right. So the first time I go through this, I write it out so that you see the mental picture of what you need to be able to do. With a little practice, you start seeing it, and it becomes easier and easier each time you practice this. So what I do is I take a look. Okay, so I see the element Mg, I see the element H, and I see the element Cl. And those are the same elements I see on the right-hand side. So the first thing I do is I do a mental count. Okay, on the left right now I'm showing 1 Mg, I see 1 H, and I see 1 Cl. I do the count on the right also. So on the right, there is 1 Mg. Here's my H's. Because of the subscript of 2, I have 2 H's on the right. And when I look at the formula that has the Cl, the Cl has a subscript of 2, so there are 2 Cl's. So when it comes to showing conservation, I have 1 Mg on the left, 1 Mg is on the right. So my Mg count is okay. But when I look at my H count, the numbers are different. I only have 1 on the left, but I have 2 on the right. And then the same thing for the Cl. I only have 1 on the left, but I have 2 on the right. So I'm going to first focus just on the H. So for the H, because the left-hand side has the lower number of H's, this is where I'm going to put a number. When I choose my number, I'm going to put a 2 here. And so whatever the coefficient value I put here, I multiply it by its subscript. So now instead of having 1H, I put the coefficient of 2. So I multiply this by 2. So now on the left, because of that green coefficient, I now have 2 H's. But H is not by itself in this formula. So whatever I put out in front of HCl, it definitely belongs to the H, but it also belongs to any other element in that same chemical formula. So this 2 also belongs to the chlorine. So I also have to multiply chlorine's subscript by the 2, and so now I have 2 chlorines. Mg is a different chemical formula because there's the plus sign between the Mg and HCl, so they are 2 different substances. So the coefficient of 2 I put in front of HCl does not affect the Mg. So I still only have 1 Mg. So now when I take a look, I have 1 Mg on each side, but now because of the green coefficient, I have 2 H's on the left and 2 H's on the right, 2 Cl's on the left, 2 Cl's on the right. So now I have the same count for each atom type on the left as on the right. The balancing is done. When the balancing is done, any substance that we did not write a number of 2 or greater out in front of has a coefficient of 1. Moving on to the next example. Okay, so a couple of things here. I'm going to start off with the same idea. I'm going to take a look. Now, I noticed that there is a substance here that is made up of 3 different elements, and that makes me think about nomenclature, table E. And I notice on table E, there's a polyatomic that is OH. So I see this polyatomic unit OH here, and when I look over to the right-hand side, I see the exact same polyatomic. So I'm going to treat the polyatomic as an individual element. So when I take a look, when I list on the left, I see in the first substance, there is Na, and the other partner to the Na is the OH. Then I look at the next substance. There is an H that is bonded to the F. Now when I take a look on the other side, I see in the first substance there is an H that is bonded to an OH. So they're both present on the left hand or on the right hand side. And then I also see an N and an Na and an F. I'm going to do my quick count. On the left, my Na count is 1. In that substance, I only see 1 unit of the OH, so I could put the parentheses around it initially to help me see it. So in here, there's only 1 OH unit. In the next substance, there is only 1 H bonded to 1 F. When I go to the other side, okay, this substance here, when I take a look, in this substance, there's 1 H that functions as the cation, and it's bonded to that OH polyatomic unit, and there's only 1 of those. And then in the next substance, there is 1 Na, which is bonded to 1 F. And even though this looks complicated, take a look. I naturally have 1 Na on each side, 1 unit of the OH polyatomic ion on each side, 1 H on each side, and 1 F on each side. So this one, when you take a look, it's naturally balanced. And that happens more often than you think. So this is what I would call a naturally balanced reaction. So that means all coefficients are 1. It's naturally balanced. Moving on to the next example, okay? So same thing, taking a look, there are no polyatomic ions that I notice. So on the left-hand side, I notice Al and I notice O. And those are the only 2 elemental symbols I see on the right-hand side. When I do my count, on the left-hand side, there's only 1 Al, but where the O is, there's a subscript of 2, meaning I have 2 oxygens on the left. Doing my count on the right-hand side, well, Al has a subscript of 2, meaning I have 2 aluminum atoms, and the O on the right-hand side has a subscript of 3. So one of the things I like to point out when I'm teaching this, take a look at oxygen. Oxygen has a subscript of 2 on one side and a subscript of 3. I call this an odd combo. That's just what I've called it all these years. I have an odd combo. And in order to correctly balance this type of reaction is you have to think of a common multiple. So the easiest way to do it is, well, I have a subscript of 2 and a subscript of 3, and the common multiple between them is 6. Also, a common multiple between 2 and 3 would be 12, right? Another common multiple would be 18. So I always start with the lowest common multiple to get my job done. So take a look here. So when I take a look, aluminum needs to be balanced. Oxygen also needs to be balanced. So I'm going to start with the odd combo, where 2 and 3 try to make them equal to 6. So over here, I have 2 oxygens, and if I put this 3 in front of the O2, that means I need to multiply its subscript by 3, making my oxygen count now 6. It didn't balance it, but now I go to the other side and I notice I have 3 oxygens. So for its common multiple, I'm going to put a coefficient of 2 out there. So now I need to multiply oxygen subscript of 3 by the 2. And now I have an oxygen count of 6 on both sides. However, On the product side, oxygen is not a lonely element, so that coefficient of 2 belongs to every element that is out in front. So that 2 also belongs to the aluminum. So that means I need to multiply aluminum's coefficient also by 2, and now my aluminum count is 4. So oxygens look good, but aluminum is not balanced yet. So my only place that remains that I can put a coefficient out in front of is the Al solid on the left-hand side. Well, what do I multiply 1 by? So it will equal 4. So out in front of the Al, I'll put a coefficient of 4, multiply its subscript of 1 by the 4, and so now I have 4 aluminums on the left. So now every formula in this reaction required a coefficient other than 1. But with that, take a look. I have 4 aluminums on both sides, which is good, and I have 6 oxygens on each side. So this reaction is now balanced, representing the law of conservation. Okay, so let's take a look at this next example. Okay, so this one will let me show you another idea or things to watch out for. So first thing, list the elements that are present on the left. I see that there's carbon, hydrogen, and oxygen. So I have carbon, hydrogen, and oxygen. And when I look at the right-hand side, I see carbon, hydrogen, and oxygen. Doing my count. Over here, this formula has the carbon in it, and it only contains 1 carbon. This formula over here has the hydrogen in it. Hydrogen has a subscript of 4, so I have 4 hydrogens. On the left-hand side, this is the formula that contains the oxygen, and it has a subscript of 2, so I have an oxygen count of 2 on the reactant side. Doing my count on the product side. Okay, so this formula here on the product side is the only place that there's carbon, and its subscript is 1, so I only have 1 carbon. On the product side, this is the only chemical formula that has hydrogen in it. It has a subscript of 2, so I have 2 hydrogens. But when it comes to oxygen, this chemical formula, CO2, plus this formula, H2O, both contain oxygen. And just think about math, because there's a plus sign. The first formula has 2 oxygens. The second formula has 1. So there's a total of 3 oxygens on the product side. Okay, so when we take a look at our counts, carbon count is okay. It is the same. Hydrogen count is different, so we need to balance that. And the oxygen count is also different, so it needs to be balanced. So here's a little rule that I tend to give out. Notice that there are 4 chemical formulas in this reaction. 3 out of the 4 formulas contain oxygen. So my rule is that when you look at if an element is in more than 2 of the chemical formulas, balance last. So I'm going to write myself a note. So balance oxygen last because it's in too many of the formulas. So if I'm balancing oxygen last, carbon is okay. Oxygen I'm waiting to do, so that means I've got to work with hydrogen. So this time there are 4 hydrogens on the left and there are 2 on the right, so I put my coefficient on the side that has the lesser number. So what can I multiply 2 by to get it to equal 4? So out in front of H2O, I'm going to put a 2 there. So I multiply hydrogen subscript of 2 by that coefficient, and it increases the hydrogen count from 2 to 4. So now my hydrogen counts are the same. This coefficient of 2 does not affect the carbons because carbon is not in this formula, but it does affect the oxygen count because it is H2O. So this coefficient, not only does it belong to the hydrogen, but also to the oxygen. So take a look here if I'm going to do this carefully. Well, my first substance is not affected by the coefficient of 2. There are still 2 oxygens there. Plus, now I have this coefficient of 2 times the oxygen subscript. So this would be 2 times 1. So now, the 2 oxygens from the CO2 plus, I have 2 waters, each 1 oxygen. My oxygen count is now 4. Carbons are still okay, 1 on each side. That coefficient of 2 in front of the water balanced the hydrogen, so now I have 4 hydrogens on each side. And take a look. Left-hand side still only has 2 oxygens, but my total count on the right is now 4. So what do I put here to raise my count from 2 up to 4? So if I put a coefficient of 2 in front of the O2, I multiply the oxygen's subscript by 2, and it raises the count to 4. So now take a look. 1 carbon on each side, 4 hydrogens on each side, and now balancing oxygen last, I have 4 oxygens on each side. So the reaction is balanced. So in the end, I understand that the coefficient in front of CH4 is 1, and the coefficient in front of CO2 is 1. Last example, raising the bar, making one that's a little bit harder. So let's take a look here. We have carbon, hydrogen, and oxygen on the left. And those are the only elements that I also see on the right. So I'm going to do my count. Well, when I take a look, carbon is 2, hydrogen is 3, but I have oxygen in 2 different substances, so I have 1 here plus 2 here, so I have a total of 3 oxygens. On the right-hand side, here's the only place for carbon, and there's only 1. This is the only place where hydrogen is on the product side, so the count there is 2, but both products contain oxygen, so 2 plus 1, I have a total of 3. So now take a look at this. When I look at my counts, carbons don't match, hydrogens don't match, but right now, oxygens match. So I'm taking a look here, okay? And I notice that with the hydrogen, okay, I see a subscript of 3 on one side, and I see a subscript of 2. So I need to think about common multiples between 2 and 3 to balance it. So I have to think common multiples. So common multiples would be 2 and 3. Well, first, of course, there's 6, there's 12, there's 18, there's 24, right? So, I mean, 2 and 3 can be multiplied by something to get any of these numbers, or any of these numbers can both be divided by 2 and 3. So I like to start with the smallest one. That's just my gut. That's where I always start. So I have a 2 here and I have a 3 here. So if I start here, and to get to 6, since that's the smallest one, excuse me, I would put a 3 here. This 3 belongs to the H in the water and the O in the water. So it changes my hydrogen count from 2 to 6. It changes my oxygen count from 1 to 3 for the water, plus the oxygen in the carbon dioxide. So I go from a total of 3 oxygens to 5. So that doesn't balance the hydrogen, and it throws the oxygen out of sync. But I'm working with this idea of common multiples. So here we go. So I now have 6 hydrogens on the right and only 3 on the left. So here's my formula with hydrogen. So to change that count from 3 to get it to a 6, I'm going to put a 2 out in front of here. Now, this 2, it belongs to carbon, hydrogen, and oxygen. So I got to be careful in my recount. So the reason I put this was to get the hydrogen count from 3 up to 6. But it also changes my carbon count from 2 to a 4. And it affects my number of oxygens. I go from a total of 3, but now I have 2 here plus these 2 of 4. So at this point, the hydrogens are okay. Oxygens and carbons are a mess. Well, oxygen is in 2 of the remaining substances, carbon's only in 1, so I'm going to work with that first. So I take a look. I now have 4 carbons on the left, but only 1 on the right. So what can I put here? I'm going to put a 4 in front of the CO2, and that 4 belongs to both of these. So here we go. So it changes my carbon count on the right from 1 all the way to a 4. It changes the carbon dioxide's oxygen count from 2 to 8 plus the 3 that are from here. So now my oxygen count goes from 5 to 7. So now I have 4 oxygens on the left and 7 on the right. And the only place I can put a coefficient is in front of the O2. So here's the thing. I've got 2 here. That means I need to come up with 5 more. What is a whole number I can put and multiply 2 by to get it to 5? It doesn't work. So sometimes you work all the way through this and it doesn't work. So now I need to come back and regroup. So I'm going to start over here a little bit. So these original ones didn't work. This happens. So I go back and I'm going to start back at my same idea, common multiple, but now I'm going to work with the idea of a common multiple of 12 instead of 6. So I got to go a little bit bigger. That's okay. So here we go. So I have 2 hydrogens here. What do I multiply it by to get the count up to 12? So I would put a 6 out front. So by putting a 6 out front, my hydrogen count on the right is now 12. Getting some bigger numbers, that's okay. But this coefficient also affects the number of oxygens. So it takes my count of 1 oxygen from the water and makes it 6, plus the 2 here. So I'm 6 plus 2. I have an oxygen count on the right that is 8. Okay? So I've made my recount. But now I'm focusing on hydrogen. I have 12 hydrogens total on the right. And right now I only have 3 because of the subscript on the left. So what do I put out in front of here to make this count of 3 to jump to 6? So I put a coefficient of 4 here. So that 4 times the 3 makes my hydrogen count 12. But that 4 also affects the carbon and oxygen counts. So I go from a count of 2 carbons, 2 times 4, which makes my carbon count 8. And it also affects the number of oxygen. So 4 times oxygen subscript of 1, 4 oxygens here, plus the 2 here. So 4 plus 2 makes my oxygen count 6. Okay, so now I'm working with even numbers, and that's a lot easier. So take a look. I only have 2 places that I can still put a coefficient. Both of them contain oxygen, which the count's not working out yet, but only one contains carbon, and the carbon count does not work out yet. So I'm going to go focus on the carbons. So on the left, I have a carbon count of 8, and I have a carbon count of 1 on the right based on its subscript. So what do I put next to that CO2 to make it jump from a count of 1 to a count of 8? I would put a coefficient of 8 right here. So that 8 definitely affects the carbon count. So 8 times 1 gives me a carbon count of 8, and those match. That 8 doesn't affect the H, so I still have 12 H's on both sides, but it does affect the oxygen count. So 8 times 2 makes this 16 oxygens plus another 6. So 16 plus 6. So I have a total oxygen count of 22. All right, so over here on the left, I only have one place that I can put a coefficient, and I need to have a total of 22 oxygens, right? So I have to do a little math here. So what I need 22, right? But I have oxygen here. I already have 4 accounted for. So this is what I need. The 4 is what I have. So this is what I have to come up and have to add. So 22 minus 4 means I need to come up with another 18 oxygens. And the only place I can do this is in front of the O2. And so what do I put in front of O2? And I can multiply it times 2 to get to 18. So my last and final coefficient that I'm going to put in here is whatever 18 is divided by 2. So I put a 9 here, which now I have 18 oxygens here plus the 4 here, which gets me to a total of 22. Little bit of practice and you're able to do these pretty easily.